On Tuesdays, 3:45 to 5:45 in Smart Group 2. Okay, so these 7 of you, please make sure you attend. When does it start? Okay, it starts on 27 February. That's the first session. Okay, then please make sure that you go home and remind your parent or your guardian to give consent on Parents' Gateway for your participation in that Olympiad. Okay, so just go and remind. Alright, any questions for the Math Olympiad people? No, okay, if your names have not been called out, okay, if your names have not been called out and you were in Math Olympiad training last time when you were in lower sec, okay, the reason why you have not been called out is because you have been reviewed, okay, and maybe not suitable to continue, okay, your Math Olympiad journey. If you want to question, okay, speak to me after class. Okay? Alright, let's start. Okay, today I must finish chapter 1.1. Okay, let's do a very quick recap over what we have learned in 1.1. Okay, so in E-Maths, right? Okay, we learned how to do completing the square. That's what CTS means. Okay, and we learned that the completed square form, for example, okay, completed square form, something like that, helps you to determine the turning point. And in this particular case, what's the turning point? What's the turning point? Negative 3 and 7. Okay, so I hope that you can see it at the tip of your fingers very easily how we get negative 3 and 7. Okay, is it negative 3 and 7? Negative 7, right? Okay, and then in this particular case, is it a maximum or minimum point? It is a minimum because if you were to expand this, it will give us a positive x squared, okay, which will result in a smiley face curve. So, minimum. Okay, so that is what we learned in E-Maths itself. How does it differ from A-Maths? Actually, this section over here is very closely linked to what we were doing in A-Maths so far. Okay, because in A-Maths, what they usually ask is not about the coordinates of the turning point, but instead it is to ask you to identify what is the maximum or minimum value Okay, to know whether is it maximum or minimum, it relies on the coefficient, okay, of x squared. So that you know the shape, then you can tell whether is it a minimum or maximum that we're looking at. Okay, value of fx itself, that is actually our y coordinate. Because what we learned at this level now is that fx and y, they are quite interchangeable, okay, quite equivalent, although they have different purposes. Okay, we should learn more when we do functions at a higher level. Okay. Another thing that is being asked, right, in A math is usually they don't stop at asking you for maximum or minimum value. They also ask when does it happen. In other words, the corresponding x value. And that also means that we're looking for the x coordinate. Turning point. Okay, so in A-maths itself, what they like to ask is that they like to separate it out. Okay, instead of asking you clearly for the coordinates of the turning point, they ask you for the value individually. Okay, for the x value and then also for the x value and also for the y value. Okay, yes, they are asking the same thing, just that it's a separate way of phrasing. That's all. Okay, so that is the difference, and you must be able to interchange between these two concepts. Okay, so let's now look at okay, let's look at exercise 1.1, question 4. Read the whiteboard. So referring to exercise 1.1 question 4, it's asking explain why x plus 3 squared plus 1 is positive for all real values of x. You may have noticed this question before and find it similar to what we did or what I've given you in E-maths. Okay? To be honest, the question I gave you in E-maths, I took it out from A-maths itself. Okay? But does that mean that what comes out in A-maths doesn't come out in E-maths? Sometimes, okay, it could be asked as well. For example, these kind of questions. Okay? To ask you to explain. Okay? So, to explain why this is positive for all real values of x, we always break it down by observing what is inside this thing itself. Okay? So inside this expression, we know that there is this part here that varies. It keeps on changing because of the value, the x value over here, because there's no certainty over what x is. So we have already learned that this thing is always going to be positive, otherwise equals to 0. Okay, for all real values of x. This is something that we are certain of. It can never be negative. Okay? So because it is always positive or equals to 0, that means that our expression over here, based on how we deal with inequalities, we will plus 1 on both sides. Okay? And we get that this expression that we have is actually always more than or equals to 1. For which we also agree that if it is more than or equals to 1, 1 is also greater than 0. Agree? So, this explains why, okay, x plus 3 squared plus 1 is positive for all real values of x. One misconception or something that yours tend to think is that when the question asks for explain, you always think that it must be written in English statements, complete full statements. Not necessary, okay? Because all this itself are mathematical statements which can be translated into English, just that we don't do that, we make use of symbols to replace certain words. Okay, of course you can write this whole statement in English, where you can say that x plus 3 squared is more than or equals to 0, but you know that it is a hassle. That's the reason why we introduce symbols. Okay, they are universally used in mathematics itself. Okay, so it is not necessary that whenever you encounter a question that says explain, it must be a complete sentence. You must look at the context itself, okay, to decide what is the best way of presentation. In this case, writing it in mathematical statements like that, from one line to the other, okay, and then concluding, this is sufficient in explaining why this expression is positive for all real values of x. Okay? Questions? Right. Someone told me? Yes. What if we put what on the list? Okay, if we put negative, will it be positive? Okay, we try that out. Let me erase this up. Okay. So our Isaac Lam over there asked, okay, what if the question is negative x plus 3 squared plus 1? Okay? Alright? Are we able to also say that it is positive for all real values of x? Okay, let's test it. We know mathematically that your x plus 3 squared is always more than or equal to 0 for all real values of x. Okay? Then we mentioned that we always multiply first before we do our addition and subtraction. We do the operation that's closest. In this case, we multiply by negative 1. And that will cause a flip in our inequality. Okay, we don't need to write the statement anymore. And then we plus 1. Okay, so what this tells me is that this expression, this function, is less than or equals to 1. Okay, so we cannot say that it is less than 0. Okay, because 1 is not less than 0, so it is not right to say this. Okay, so actually for this statement, the question how it will be asked is maybe asking explain why this is always less than or equals to 1. Okay, they will never ask you to explain why this is positive because it is impossible. Okay, it is only positive for a certain value or certain range between 0 to 1 only. Okay, yeah, between 0 to 1, so 0 not to 1. Yeah. Okay. So, yeah, this is a example okay, that shows us that it is not positive for all real values of x. Is it? Okay, we do one more, try for in your textbook page 6. Not true, okay? So you need to have more evidence to support that. Because the thing is that x over here, if it is a negative number, negative and negative will make it positive already. Okay? So the evidence that you're trying to provide just now by saying that minus sign all over means that it must be negative, that doesn't hold. Okay? So what we need to do is to borrow the ideas that we have over here. Because we are very certain that once you square something, it is always positive. Then it is about manipulating our inequality. Okay? So, with this case over here, we must first factorize out the negative sign because That is the only way then we can do our completing the square. Okay, it must be positive 1 coefficient of x squared. Okay. So we get this, and then we have negative x plus, in this case 2 square, minus away 4 plus 10, 6 plus 6. Okay. And then we get negative x plus 2 square minus 6. So this is our completed square form. Okay. Yeah. Oh, sorry. Thank you. Is it better? Correct? The completed square form. 8 plus 6. Yes. Yes, Yong Le. Yes, you are free to go with my lesson form. Yeah, this one is actually yes. Yes. Not yet, I'm not finished yet. This is just the working for completing the square. Okay? Okay, so with our completed square form like that, then now we know that this is more than or equals to 0. Okay, we have placed all the variables, the x, into this part here rather than having it individually. Okay, so having it expressed this way, okay, then now I will multiply by negative 1, which causes my inequality sign to flip, followed by minus 6, because this is the thing that I want to show that is negative. So it becomes less than or equals to negative 6, for which we know negative 6 is less than 0. Okay, and therefore we can say that this is negative for all real values of x. And that's how we show it. Okay? Yes?
Can we immediately skip to the steps where we write negative x plus 2 square in
This one?
like the one on top,
This one?
without writing the one
This one, I would prefer us to start from here because this is the origin from where it starts for us to be able to complete this. Yeah, so I do not encourage you to skip directly to this.
but
Yeah.
your mark will be deducted if you skip.
You try lah, then after you will know. Yeah, because I cannot confirm with you all the time, right? Okay? Yes, yeah. Skip this one, go here. Why you keep on running skip steps? Yeah. You all got that short time there. Okay? Give us the whole thing. Okay? I don't want answers now. Okay, skip here, skip there. I give you the best quality leh. Okay? Have I ever shortchanged you in something? Okay? I can also skip, but do I do that? I don't, right? Yeah. Okay? So don't shortchange us lah. Okay? Confirm got time one. Yes, either you want to. Yes, you should write that. Now you remember how I know that. Okay? Any other questions? Actually, not much. Yes. You must write bracket shown. Okay, when you show Exercise 1.1 homework. Are you ready? Okay, next. Now we start on chapter 1.2, unit 2, right? Okay, let's look at try 6 first in chapter 1.4. Okay, in chapter 1.2, what we're trying to do is to link two concepts together. Okay, first thing, when we solve a quadratic equation, okay, we get solutions, right? So for example, if I'm trying to solve this equation over here, okay, what we get out of it is solutions. Okay, which has another word for it. Okay, instead of solutions, it is also called roots of the equation. Okay, so there is another word for it. And then in our events, we have learned that it is also considered the x-intercept of our quadratic curve that we are able to draw. In this case, if I were to draw the graph of this, I'm not sure whether this is correct or not, the graph. But the roots are also have the same meaning as the x-intercepts of the graph. Okay, so the key thing when you learn A maths is that you must be able to interchange all these terms that you encounter in the entire syllabus itself, be able to link all of them up, and know that what you're asking for is actually always the same thing. Okay? Okay, so we start off by looking at try 6 first. Something that we're familiar with. If you want to find the x-intercepts and the coordinates of the turning point, essentially we're trying to solve this quadratic equation. So to find our x-intercepts, we're taking y to be equals to 0. Okay. To solve from here, there are many ways that we can do it. Okay, we can do our factorization. Coincidentally, this one can be factorized. Or you can do your formula. Okay. You might not be able to see that it can be easily factorized in this form, but if you divide across by -2, okay, you might be able to see it easily because 2 has factors 1 and 2, such that we can have -2 and x plus 1. Okay? Because negative 2x and plus 1x, it will give you a minus x. Okay? But if you cannot do it at that speed yet, please do your cross method. Okay? Otherwise, do your formula. Also fine. And then we get the solutions x equals to 2 or x equals to negative 1. Okay? Then for the turning point, what we already learned in Emaths is that the x coordinate can be computed by taking average of the two x-intercept value, and that gives us half. Don't if you continue talking to my Z, okay? When you sit in my Emaths class, I want to sit you in the corner. Okay? So x coordinate will be half, and then our y coordinate will be found by substituting x to be half. Okay, so this process itself, I hope you're familiar with that. Okay, which leads to our turning point to be half and 4.5. idea first today. Okay, then tomorrow we will definitely talk about discriminant like what I have said.